because why am I recording? Because I didn't record in the last class and I wrote on the board. Oh, you can't see what I'm writing. Can you? That doesn't work. Okay, so and I hit this thing. I better pause for a second. While that screen comes on, I'm gonna draw some stuff. I like to draw pictures. There's a box. We'll draw a box here. There's a box here. This is 5.2. F of x. F inverse of x. Okay. And I take 3, plug it in here. I get out 5. I take 5. Plug it in here, I get out 3. So an inverse function is basically it's an undoing function. Okay, so basically if some function wraps something up and spits something out, the inverse of that function takes what you spit out, unwraps it, and spits out what you put in the first place. That's basically the idea between it's basically what an inverse function does. So for example, and this sometimes I'll call this f inverse of x, sometimes I'll call the inverse, so this does not mean f to the negative 1 power, it means the inverse of x, okay? So simple one, say I have f of x is equal to x plus 2. What would be the inverse of that function, f inverse of x? So if I add 2 to some number, what would undo adding 2 to that? What would undo subtracting 2? So the inverse of that would just be x minus 2, right? And you can check to see if that works by taking a number and plugging it in. Let's take 7 for instance. If I take 7 and plug it in here, I get out what? 12, very good. No, 9. Okay. And if I take 9 and plugging it in here, I get out 7. So what I put in here, I get out something, and I take that something, I plug it in here, I get out that. And if it's truly an inverse, the machine works in both directions. So if I were to take a number like 0 and put it in here, I get out, say 0, what do I get out? 0 minus 2 is?
Negative 2.
Negative 2, and negative 2 plus 2 is?
2.
Negative 2 plus 2 is? 0. Okay? So if it's truly an inverse, it will work for every value, either forwards or backwards. Okay? Every value in the domain of both of those functions. Okay? So okay? So here's kind of something to know. Okay? That f and g, it's hard for me to write neatly, but I try as well as I can. F and g are inverses. Inverses. Can you read my writing? Inverses. If and only if. If and only if. Okay. F of g of x. F of g of x is equal to g of f of x, I don't know what that trash can's doing, is equal to x for all x in the domain of f and g. Okay? So, okay, so what that means is that if I take one function and plug it into the other function, I'm going to get out x. And if I plug in that other function and plug it into the original function, I'm also going to get out x. For instance, show that f of x equals x cubed and g of x is equal to cube root of x are inverses. Inverses. I'm done, right? Done with that. So all you do is you take one function and plug it into the other function. So f of g, I'm going to use different notation just to f of g of x to get used to seeing both types. This means the same as this, right? So f of g of x, f of g of x, this means the same thing. F of g of x looks like I take g of x and I plug it in there, right? So f of g of x looks like the cube root of x cubed, right? What do I get if I cube root the cube root of x? X. Do you understand why I get x? Because this is like x to the 1/3 power, right? This is equal to x to the 1/3 power raised to the 3rd power. And remember, you multiply the exponents and you get x. Remember that? Okay? And if I go backwards, I have to show it's true in both directions. So g of f of x is equal to, so g of f of x says take this and plug it in there. So that says take x cubed and take the cube root of x cubed, right? So that's like x to the 3rd power raised to the 1/3 power, which is also equal to x. Okay? So that works. The domain of x, and then can I plug in any number into x cubed? Can I plug in any number into cube root of x? Can I take the cube root of any? Yes, you can. Okay? You take cube roots of negative numbers, right? Because like negative, cube root of negative 8 is negative 2 times negative 2 times negative 2. Yeah? Okay, so that works. If I graph these two things, I did this on my graphing calculator in the other class because it looks cooler. Where's my graphing calculator? Where is it? I had it. There it is. Okay. So clear y equals. So if I graph these two things, first I'm going to graph y equals x to the 3rd and y equals the cube root of x. Okay. I get this graph. There's y equals x cubed. There's y equals the cube root of x. I'm going to go zoom square to get a square viewing window, so maybe you could see it better. Oh, that's not really better. What if I did zoom? I'm going to zoom in. Zoom in. Okay. And so they're kind of flips of each other. If I graph this line, y equals x, graph, what do I notice? Do you guys remember this from last year? What's it? This is the line y equals x. What's true about this curve here and this curve there? The reflections over the line y equals x. So inverses in general, they're reflections over the line y equals x. So that's the next page, okay? Reflections over the line y equals x. I guess I should say inverses are. Inverses are. Okay? So for example, how's my axes here? Here's the line. Here's this. Here's y equals x cubed, kind of. goes, let me try to do this right. Y equals x cubed, kind of goes like that. Okay, here's the line, y equals, let's make it dotted. Dotted line, should use a different color. Y equals a cube root of x will look something going like this, and then, oh, that's bad. Going like this. And going like this, that's bad. But you get the idea. But if on this line, so say here I have the point, if this is y equals x cubed, okay, and I have on this line, I have the point 2, 8. What has to be on this curve over here? This has to have the point 8, 2. Okay? The x's and the y's switch places. Okay? So if this has 2, 8, this has 8, 2. If this has -1, -1, which it does, both of them have -1, -1, right? This one has the point, this one has the point, what's the cube root of -27? What's the cube root of -27? 3. -3. So if this has -27, -3 on it, what's this going to have on it? Switch places with the x and the y. -3, -27. Okay? So sometimes, right? -3, -27. So what they'll say sometimes, they'll like draw a graph, and they'll say that's a bad graph, but they'll have some funky function that looks like this, and they'll say here's the point 0, 1, here's the point 3, 10 or something. What would, and they say sketch the inverse. What points would have to be on that inverse?
1, 0.
You'd have to have a 1, 0, right? A 1, 0, and then you'd have to have a what? A 10, 3, right? And so if I'm sketching the inverse, which this kind of looks like a log function, do you guys remember logs from last year? One might be an exponential function. The inverse of an exponential function is a logarithmic function, and those are reflections over the line y equals x, right? Okay? So that's that. God bless you. As far as finding inverses, does anyone remember how to find inverses? Find. What do we do? Very good. You switch the x and the y. Finding the inverse. Okay? And then you solve for y. So finding the inverse, switch x and y and solve for y. I guess that would be step 2. So for example, say I have y equals x squared. X, that doesn't say x squared, does it? X squared plus 2. And they say find the inverse. Inverse. So what would I do? X equals y squared plus 2. Then what? Subtract 2. So you get y equals x minus 2. Y squared equals x minus 2, right? So y is equal to what? Aha, but there's 2 parts to it. There's a plus or a minus. Yes?
Yep.
Okay. Which one's the inverse? It depends which half of the graph you're looking at. Okay? So because of that thing, a function can only have an inverse if it's 1 to 1. So if this is y equals x squared plus 2, y equals x squared plus 2, then one inverse, and this goes through the point 0, 2, right? This is going to go through the point 2, 0, right? And it's going to go like this. This is the top half. and this is the bottom half, okay? Is this a function? Is this a function?
No.
This is not a function because it doesn't pass that vertical line test, right? So what you have to do, I guess I should write something else. In order for something to have an inverse, I can't write and look that way. I have to come over here, okay? In order for a function to have an inverse, it must be 1-to-1. Which means for every x there's exactly one y, and for every y there's exactly one x. It has to pass the horizontal line test. So if I were to take a ruler or whatever, a straight edge, this one, I could, whoops, that's not right. It does not pass the horizontal line test. Why is it, where's my, I don't want to do that. I want to do this. I want to grab my line tool. That's what I want to do. Okay? This one does not, it's not 1-to-1 because for every x, there is one y, but for every y, there is not one x. So for y equals something up here, there's more than one x. You see that? So in order to have an inverse, it has to be 1-to-1. But what you can do, you can find the inverse by what's called restricting the domain. So if I say, find the inverse for x is greater than or equal to 0, what would be the inverse? Would it be the plus part of this or the minus part of this?
Plus.
It'd be the plus part because you're talking about the inverse. So you could think about it graphically, right? For x is greater than or equal to 0, you're talking about this part of the graph, yes? Okay? So the reflection over y equals x would be this half of the graph. Or you can just say, well, it's the plus part of this function. So minus square root of x minus 2. If I graphed it, I get this half. So if I wanted the bottom half, I would have to restrict my domain to x is less than or equal to 0. Yeah? Okay? So that's that. Am I talking too much? Don't fall asleep yet. Should we stand up and sit down? You want to stand up and sit down? Stand up and sit down! A couple times. There you go. It's good for your brain. Yeah. Not again. No? You don't want to do this? You want to dance? You want to see me dance? No, you don't want to. Okay. Last thing. Okay? And then we'll be kind of done. Okay? And then I don't think the homework is as bad. But find the inverse for f of x. So this is kind of a tricky little problem. For f of x is equal to x minus 4 over x plus 2. So I would kind of pay attention to this because I think it pops up on the quiz and it pops up on tests. And state its domain. State the domain. Should really state the domain and range of f of x and f inverse of x, or g of x, or whatever you want to call it. So my first step, I'm going to rewrite this. Well, first I'm just going to, I don't like f of x. F of x is the same as saying y, right? Y over x minus 4 over x plus 2. Now what? Switch x's and y's, okay? So this becomes, oh, I like that green. That's kind of a teal. Okay, so we have x equals y minus 4 over x, y plus 2. And now you have to get y by itself. So what do you think I do first?
Multiply.
Yeah, yeah, you multiply it, you cross multiply this across. So that gives you, so next you get y plus 2 times x equals y minus 4. So this is kind of an algebraically tricky problem. Anyone want to guess what I do next? Distribute. Who said that? Very good. Okay? You distribute. And you get yx plus 2x equals y minus 4. Now here's a trick. Okay? Oops. Did I do that right? Yx plus 2x. Yeah, that's right. So here's a trick. So here's step 1, step 2, step 3, step 4, I distributed. Step 5, I get everything that has a y on one side and everything that doesn't have a y on the other side. Okay? So I go, because you'll say, I can't solve for y because I can't subtract y over here, but there's a trick. Okay? You get yx minus y equals minus 2x minus 4. Does everyone see what I just did? Okay? Can't see that back there, Emily? So I brought this 2x onto this side, I brought the y onto that side. Then I factor out a y from the left side. Now I have just y by itself. X minus what? Minus 1. You guys see where I factored out this y from both of these terms? And now I got equals 2x minus 4. Now what I do? Divide.
Isn't it negative 2x?
Up minus 2x, thank you. Minus 2x minus 4. Divide by x minus 1 and I get y equals minus 2x minus 4 over x minus 1. What's the domain of this function? This is f inverse. We'll say f inverse of x, right, is equal to y, which is equal to this. What's the domain? X cannot be equal to 1. What's the domain of this? X cannot be equal to negative 2. Now, what happens, the domain, you know what the range is? What's the range? You guys remember what the range, what's the range? The possible y values. If I graph this function, did you guys do rational functions? I don't know if you did. But if I graph this function, it has, we'll talk more about rational functions later on the semester. But if I graph this rational function, this one kind of looks like this here, and then it has an asymptote at 1. Okay, so actually, if I graph one function, this is really slow. But if I graph this function, it has asymptotes at negative 2 and 1, and it kind of looks like this. Right? If I graph this function, it has asymptotes at x equals positive 1 and y equals negative 2. Okay? Y equals negative 2? Yeah, y equals negative 2. So if I graph this one looks like this. So what happens is that the domain of this one is the range of this function, and the range of this function is the domain of this function. Don't worry too much about that, okay? But just so you know, with inverses, the domain and range flip places, okay? That's all I have to say today. How much time we got? You don't have to apply. Okay, so your homework is, what is your homework? It's on Schoology. Where's Schoology? Is this Schoology? Here it is. Summer Packet 2. Notice that, you guys, I'm very nice to you. I posted somewhere on here, I posted, I think if you go up here, I posted that's not what I'm doing. It's not here. summer packet solutions, okay? So if you want to study and look at how I did those summer packet problems and see how they're done, if there's still things you're confused about, you can look at that. Your homework for tonight is right here. I'll make that bigger, okay? How do I do this? I can grab a picture of it. Here we go. Face capture, new page. Whoa. I am a technological marvel. Wow. Oh, there you go. Okay. So that's your every other odd. So that's not that bad. We figured out in the last class it's 1 through 6, and this is like 18 problems, I think. It's not.
Would it be then like 7, like 11?
Yeah, 7, 11, 15, and there's only one part to each one of these. Okay, it's not like 37 parts. Okay, like in last night's homework, and